The next rule that we're going to look at is the product rule. If you are given a function f at x equals h at x times g at x, so a function that is made up of two smaller functions multiplied together, then the derivative, f prime at x, is the derivative of the first function, h prime, times the second function, plus the first function times the derivative of the second function, g prime at x. In words, f prime at x is d first, or derivative first, times second, plus first times derivative second, or d second. The first example is quite simple. F at x is equal to x to the fifth times x cubed. Instead of using the product rule correctly, I'm going to do this question incorrectly. It's a common mistake to think that the derivative of a product of two smaller functions is simply just the derivative of each of these multiplied together. So if I applied the product rule incorrectly, I might write f prime at x is equal to the derivative of x to the fifth, which is 5x to the fourth, times the derivative of x cubed, which is 3x squared. And then if I expanded that, I would end up with 15x to the sixth. This is wrong. Let's actually take a look at the function f at x, and instead of taking the derivative first of all, let's expand it. So x to the fifth times x cubed is x to the eighth. And now we can apply our power rule to this single term. So we know that f prime at x is actually 8x to the seventh. So the exponent comes down front, and I subtracted 1 from the exponent. So I get 8x to the seventh. And we know that we expanded correctly, and we applied our power rule correctly. So this is definitely the right answer. This confirms that 15x to the sixth is definitely wrong. So let's get rid of this. Now let's apply our product rule correctly. So f at x equals x to the fifth times x cubed. This is our first function, x to the fifth, and x cubed is our second function. So the product rule says that f prime at x is equal to the derivative of the first thing, 5x to the fourth, times the second function, not the derivative of the second, but just times the second function, plus the first function, which is x to the fifth, multiplied by the derivative of the second function, so 3x squared. And now if we expanded each of these groups, the first group gives us 5x to the seventh, and the second group is 3x to the seventh, and collecting like terms, we get 8x to the seventh. And that confirms what we found when we first expanded and then applied the power rule. So applying the product rule correctly gives us the same result. Let's take a look at a more complicated example. Here we have a function f at x equals x squared minus 3x in brackets multiplied by 3x to the fourth plus 12 in brackets. So here we have a function that is the product of two smaller functions, and we could actually expand this. That would be one approach and get several terms and take the derivative, but we can also take the derivative using the product rule. So let's identify the first and the second. So x cubed minus 3x is the first function, 3x to the fourth plus 12 is the second function. And recalling our product rule, f prime at x is d first second plus first d second. So f prime at x is the derivative of the first. X squared becomes 2x, minus 3x becomes minus 3, times the second function. Not the derivative of the second function, but just the second function. So d first times second plus first, so just write the first function again, x squared minus 3x, and I multiply by d second. Derivative of 3x to the fourth is 12x cubed. Derivative of 12 plus 12, this is a constant, so the derivative of a constant is 0. So I have plus 0, but I didn't include that. I'll just have 12x cubed for that second derivative. So this is the derivative of f prime. It's not simplified. If I was now going to find the slope of the function f at x at a particular x value, I probably would substitute the x here. So I put the number in here and substitute x's for numbers and then simplify. That might be easier. If you were asked to find the derivative in simplified form, then you would have to expand each of these groups and collect like terms. So again, recapping the product rule, if you're given a function that's the product of two smaller functions, then f prime is h prime g plus h g prime, or in words, f prime at x is derivative of first times second plus first times derivative of second.